We get a round of applause for Dan Strack. There's more beers on the table too. Sorry.
Okay, right. Evening all. So after the hope and optimism of the last presentation, we were all looking forward to an indefinite lifespan. Unfortunately, mine's going to be a bit of a downer in terms of the machine will be out to kill you, and you're actually designed to do so. A bit of a background. One of the various hats that I wear is I'm a legal officer in the Australian Army Legal Corps, SO2 Legal at 6th Brigade out at Murray-Young, Salisbury, in a reserve capacity. This presentation is an update of my master's thesis. So I was talking to Peter at one of the earlier meetups where I was updating my thesis to publish in a journal, and he said, give a presentation. So I said, yes, why not?
You do this.
So to start off, just to make myself sound a bit clever, I start off with a classic quote. So you may not be interested in war, but war is interested in you. By this guy, anyone can identify the speaker who that interested to? Freud? No. Any other guesses?
Is he Russian?
He is Russian, yes.
Artificially generated. It looks like it.
So 100 THC coins for anyone. It's Leon Trotsky. So what he meant by that is you can interpret it in two ways. Firstly, warfare and the methods and means of warfare is something that we should pay attention to. It's something worthy of study. Also, you can interpret it to mean that you may have a perfectly peaceful life and all the rest, but one day your neighbors or your neighboring nations may be out to get you. So pay attention to this space. So the scope of today's presentation. So is drones, artificial intelligence, and robotics revolution in military affairs, and in what ways? Its current use in current and previous conflicts, especially say Afghanistan and the current Russia v Ukraine war. What is the future outlooks of these technologies? And my particular focus as a lawyer, the legal issues and conundrums that these technologies throw up. By the way, these views are exclusively my own, not that of the Department of Defense, yada yada, all these information is all public domain. I'm not involving in secrets here. And Chatham House rules with regards to discussions, etc., etc. Okay, so what is a revolution in military affairs? So an RMA is defined as where it results in a nation seizing an opportunity to transform its military during its doctrine, in terms of doctrine. For those of you not familiar with the term, is basically the procedures, the set standards operating procedures in which an army or an armed force goes to war in. So there's doctrine with regard to planning, logistics, ISR, intelligence, etc. So where was I? In terms of doctrine, in terms of training, organization, equipment, tactics, and operations and strategies in a coherent pattern in order to wage war in a novel and more effective manner. So previous RMAs, you can think of, say, the invention of the dreadnought warship in the 19th century, or even the gunpowder and the advent of the machine guns and pistols, that sort of thing, overtaking previous bows and arrows, those type of weapons. So this is the type of concepts the revolution in military affairs takes into account. Okay, so definitely AI and robotics, or we refer to them as autonomous systems, is on the radar of the of our defense force and those overseas in America, China, and other military nations. So in the 2023 Australian Defence Review, it's definitely identified as artificial intelligence amongst the other plethora of technologies out there as something we're going to focus on in the future. For some reason, the animation didn't quite work, so it's supposed to circle artificial intelligence and autonomous systems here, amongst other things such as electronic warfares, innovations in communication systems, even biotech and other such systems. So definitely it's something that the Australian Defence Force is keen on developing in our future. Okay, so firstly, to start off with is why these technologies will revolutionize the methods and means of warfare now and in the future. Well, first of all, reduction in and risk of loss of life. If you take the human out of the equation in a lot of these technologies, then you save not only the person's life, but that's one less salary that you have to pay, and also in terms of targeting, say future like 6th, 7th generation warfighting aircraft. There are various things that you can do with an autonomous system that you can't do with having a human in the pilot seat. So if you subject an aircraft to various G forces at a certain upper limit, the human body will just give out. Whereas if there's a robot brain behind that aircraft, then you can exert more G forces to its maneuverability and other such things. Also, another example I'll give you is modern warfare. A lot of the time, you don't target the enemy's forces themselves. You target their lines of supplies, lines of communications. So the trucks and such supplying the weapons, the food, etc. So if you can take the human out of the equation, you've got more efficient logistic routes, and also it's one less soldier, one less truck driver to target, one less life to lose in that particular operation. These systems can be more accurate and efficient in terms than regular soldiers. So, like a lot of artificial intelligence technologies, once it reaches human level, it quickly then surpasses human level. So think of chess or Go. Once the AI system was able to match the world's best chess player, the world's best Go player, it quickly then not only just stayed in place, it then developed a superhuman level of skill in terms of chess playing and Go playing, in that no human on earth could ever beat it. Same with this, when technology such as pattern recognition and identification of, say, remote intelligence data, once they can recognize patterns, images better than a human being, it just doesn't stay at that level. It's on that upward accelerated curve, and it becomes superhuman in its capabilities. These systems can require less infrastructure and logistics to support them than the cost of human soldiers. So the ratio of combat troops to other support personnel, such as logistics, medical, legal, chaplaincy, etc., it's something like 32 to 1. So for each one combat soldier you're putting in the field, you've got 32 personnel supporting that person in terms of equipping him or her, writing his last will and testament. I sound quite a lot. I'm very much the echelon, unfortunately, and medical support and all that. So yeah, a robot obviously does not need a compensation plan. It does not need superannuation, medical support, chaplaincy services, etc. And these systems can also be deployed in conventional or asymmetric hybrid warfare. The Ukraine, if anyone follows the Russia-Ukraine
special military operation.
Yes. Well, I'm not, unfortunately, we are not subject to Putin's censorship, so we can call it what it is. It's an invasion and a war of aggression, which is illegal under the UN Charter. The only thing stopping us, is that Mike is right in the international law. There's no international police to go after Putin, unfortunately. So the UN Charter really only works for small nations which had no allies. But for those larger players, the Security Council, they have the veto power, etc. So anyway, going off on a tangent there. If you look at the Ukraine v Russia war, these systems have been highly used and also highly innovative in terms of especially use of drones, where in terms of asymmetric warfare, being that a small force taking on a much larger force, you've got like $10,000 drones taking out $100,000 systems or multi-million-dollar systems. You've got use of drones, and I'll go into this in much further detail in later slides. You've got use of drones in ISR, that is intelligence, surveillance, and reconnaissance, in terms of replacing the traditional artillery spotter, in terms of putting that laser sight on the target to call in the artillery and that sort of thing. So certainly, well, it was a rhetorical question, but I think everyone, in terms of in the military space, do recognise that this is a fundamental shift in the way we conduct warfare, and it will continue. The innovation space of this will continue within foreseeable future. Okay, so focusing firstly on drones. So this talk is going to less focus upon the technology, which is like a 2-hour presentation in itself. It's going to be more of a discussion on, as I said, the legal and ethical conundrums that these technologies throw up at us, in terms of, especially in terms of the military is going to increase the adoption and use, and so what does that mean for us as citizens, as a species, as human beings? So, just to segment into focusing on each of these technologies a bit. So drones used. These are the current roles, that sort of a summary of the current roles that it's currently playing. So ISR, as I said before, battlefield coordination. So in terms of conducting your military operation, an organized force will always beat a ragged mob. So if the side that best coordinates its troops is mostly the ones that will benefit on the battlefield. Direct kinetic effects. So the drones being used for in place of long-range missiles. So the problem with long-range missiles is they're detectable by radar, and they have only a certain range. What you're finding in Russia-Ukraine war, for example, is that you can sneak in the drones in small parts, assemble it on site, and then just fly it off to the airfield, and then it taking out those strategic bombers, as has been on the news in the last couple of days. So and also having a smaller logistical footprint in terms of the missile, having to have missile ears and the other infrastructure that you can think of that is behind launching a missile, whereas these are like 4-man, 5-man operations going into Russian territory, setting up, taking out the target, and then banging out of there. So quite a smaller footprint, and in terms of finance, quite a cheaper way to do it. Asymmetric warfare, like a $20,000 or $10,000 piece of equipment, taking out a much more valuable target, costing tens of millions or even hundreds of millions of dollars. And also, one thing that is overlooked is the psychological info ops effects of these things. So a lot of the footage we get of the battlefield these days is through drone technology. So if anyone, as I said, if anyone follows the war day to day through YouTube or through CNN, etc., etc. You have a lot of the footage you see is through drone technology, so that has a psychological impact in terms of, say, for us as an allied nation of Ukraine, we can see that our equipment, our financial support is being well spent. It's not being completely wasted. And also, if you're on the other side as a Russian soldier or a Russian citizen, you've got to get the real-time picture of what is actually happening on the battlefield behind, that great wall of censorship that the Russians are trying to put up. Okay, what is this about? ISR. Okay, so this is just a further. I'm not going to spend too much time on this slide. Some further roles of the drones. So it creates a virtual planetarium. I know what that is. So in the old days, if you had the old prison system, that was the central tower in which you could watch all the prisoners. So basically it refers to a virtual 360-degree view of the battlefield, again, for battlefield coordination and psyops. An unprecedented awareness of key information points on the modern warfare. Again, command and control, so the commander can see where his troops are, where the enemy troops are, and coordinate the battle accordingly. Used as mobile artillery spotters for short-range, medium-range fires. So even with all the modern tech that you see on the battlefield these days, land warfare is still pretty much a kinetic space where dominated by artillery and armored vehicles, tanks, armored personal vehicle carriers, that sort of thing. So if you can get a high ground view of what's happening on that battlefield, then you can coordinate your long range fires and guide your strikes to be more precise. Okay, next slide. Obviously, in the Afghanistan war, the Reaper drone was made quite famous. Targeted assassinations on the remnants of Al Qaeda and the Taliban. And currently, Ukraine is making much use of these TB2 Turkish drones in taking out a lot of high-value Russian forces, especially their surface-to-air missile systems and the battleships still operating out of the Black Sea. And in terms of info ops, the plethora of drone footage that's uploaded on YouTube, Twitter, Telegram, etc., creates an unprecedented awareness of the day-to-day conflict. The torrent of information helps boost military and civilian morale. Well, it depends on which side you're on, obviously, but certainly anyway, and creates global awareness of the conflicts and boosts the economic and military support of the help being given to Ukraine. So the US and its allies can hopefully have some, can see that their military aid, those billions of dollars that are being given to Ukraine are being spent wisely. Okay. In terms of future concepts, now the key vulnerability to a UAV is, okay, two ways you can take out a UAV physically, genetically, that is through the just shooting it down basically, and there's an Australian startup company, Dragon Shield or something like that, that's doing quite well out of its systems, out of its anti-UAV systems at the moment. But the real really efficient way of doing it is to target the signal. Obviously, there's a signal between the operator and the drone. If you can take out the signal, then you've taken out the system itself. In future, what people are working on is taking out that vulnerability. So how do you eliminate the signal? You make it so that the drone itself can make its decision in terms of target detection and targeting. So obviously we're talking about autonomous lethal robots here, which is worrying in some aspects, I guess. So you're taking the human out of the loop. So this hasn't been quite. There are some. There are, to the best of my knowledge, there are no autonomous drones at the moment, but there are some autonomous lethal systems up there. So, for example, on cruisers and destroyers, the naval ships, some of their anti-missile systems are autonomous. If they detect a missile coming in, there's no human in the loop in terms of that system taking out the incoming missile, because the time space is too short. There's no use for having a human in that time loop. By the time the human makes that decision, the missile has struck the ship. So that is an example of a system that has already gone autonomous. So autonomy also promises more accurate targeting as well. So as I said before, in terms of image recognition, currently, if it's being done by humans, it's still subject to all the fallacies of a human being in terms of eyesight, pattern recognition. The person may be tired at the time and may not have had lunch, that sort of thing. The autonomous system does not have any of those flaws. So if it improves to human level of recognition of images of targets, then it could, at some point, surpass our abilities to more accurately target something. And there's been very tragic examples of inaccurate targeting. So the last day of the Afghan war, or the withdrawal, the American withdrawal from Afghanistan, the Americans after the bombing on the previous day thought some father driving around Kabul just delivering water bottles. They thought that car was an insurgent going to an attack, because there was some intelligence previously that there was going to be a car bomb that day. So they took out that person who was just innocently, and their father wasn't only the father; he had 3 kids in the back of the seat as well. It's a war crime. So essentially, but yeah. So that's an example of a human error. So if you think that autonomous systems could lead to tragedy, at the moment, human systems are just as flawed. Yeah. Okay, and another future concept of drone warfare is the nightmare of swarm bots. So if you've ever seen any of the sci-fi films on this, this is actually being developed. But so it's basically a swarm of robot drones coming after you. If that's up to get you.
Sounds like a Stephen King.
Yeah, there's various Netflix series that you can watch. All the time, examples of swarm robots. Okay, moving on to robotics. So robotics is pretty much just another form of autonomous systems, but I've identified it as a category in its own because so the rationale for having robotics replace human systems is the 3 H's. So if a work is hot, heavy, and hazardous, it's better to set in a robot than a human being. Think the Fukushima nuclear disaster. You know, it would have been better for a robot to have come in, shut that thing down, make it safe. They'd have sent in all those Temco workers who are probably being massively irradiated and could probably develop diseases in future. The 3 Ds, dull, dirty, and dangerous duties. Same rationale. Similar with drones, there's no worry of casualties, no worries of prisoners of war. So if you destroy the drone, if you capture the drone, there's no other drone to write home to or send the chaplains to send condolences to.
When you say no casualties, you mean
Lots of daily
so when you mean no casualties, you mean to take the drone and put the drone that's going to kill somebody.
Yes, this is
human being.
this is
So no casualty to the people coming in and invading.
this is bringing that perspective of friendly forces against the opposition.
Right. So that's
Certainly casualties on
are
the
you
other.
definitely human being?
Well, Well, as an officer of the profession of arms, our aim is actually to kill the other side.
Which is not.
Remember the frontier? That's exactly why I
And you just demonstrate very clearly that the only person to celebrate water was killed with these prejudices. Like, just go, but it's a very sensitive subject, so go in.
Okay.
And the self-driving cars that knock down all the people.
And the Pentagon did apologize.
Oh, they apologize.
Moving on. Okay. So reduce public backlash.
You get drone footage of robots massacring people, there'll be backlash. Yeah, but it's okay when robots kill other robots for robot wars.
Don't put it on radar, you know?
But that's not what they're talking about.
The US
Yeah, let's start.
Come on, guys. Come on, guys. It's 1800.
As obviously, as a Western nation, our society has invested an appetite for capabilities than say Russia, which has lost something like 200,000 soldiers.
But then it's not the politicians at the top making decisions, the whole people are suffering. So it's their lives. So but there's a big fake taxes looking at our involvement.
Yes, an excellent point. I will address that in my last. Okay, and yada yada yada. Let's move on. Okay, so this is an example of the current system that autonomy is being built upon. Obviously, it's not an exhaustive list, and this is nothing secret as well. If anyone is interested, it's all found on the web, the worldwide equipment guide on OpenNet. So if you're interested in military equipment, you can look this up, and it's all there. So it's basically air, land, and sea. So land systems, air systems, and ocean, sea systems are all being automated. In fact, there's actually a Pentagon directive, which says that if any system can be automated, if there's anywhere in the chain that a human can be replaced, then it's optional to do so. Again, saving money, lives, etc. Etc. Okay, some other examples on the web of the small systems that are being used, especially in terms of, say, mine detection. They're even putting machine guns on these small rovers at the moment, as you can see. So, extremely interesting stuff, as I'm sure everyone will agree. This really isn't the audience. This presentation is.
Before you move on, though, Sam,
Yes.
just on that last slide, the general direction of warfare in America and Australia is been to light rapid infantry. Is that correct? In terms of-
Yes, exactly. But there's also always the danger, as we always have been told on our courses, that you're fighting the last war. So previously, we were being built for sort of like asymmetric counterinsurgency type warfare, like Taliban, Al Qaeda, etc. With war in Ukraine, we're now rediscovering the value of tanks, artillery, and other mass kinetic systems. So, you don't know what future warfare. Oh, you cannot make an estimated guess. Yes, was the question.
Yeah, what's the difference between the war in Afghanistan and this one? From your point of view, why there was this spike in technology, and what happened to the laws of robotics from Asimov? One of them said,
Okay, it's a kind of technical question, and this is my guesstimation, my sort of best guess, and it is the accessibility of the technology. Once the iPhone was invented, that led to, because of the miniaturization of the electronics of the supply chain that the iPhone and the smartphones enabled, that then enabled virtual reality drones, and it just gets cheaper and more accessible. So previously you had to purchase $1 million drone. Now they're making drones out of cardboard. These Kami's one-use drones out of cardboard virtually now, and then setting it off in its way because it's the sensors. It's not the airframe itself, it's the sensors that you put on the drones. That's been the innovation.
Could war be fought purely with? I could see war being fought purely with drones.
Yeah.
Nothing else.
And that would be my hope.
But on both sides, the machine gun was brought in to end the war quickly, but when they both got it, they could just kill more quickly. So I see a drone the size of a fly going onto King Jong-un's head and just go boom, just C4 and problem solved.
But both sides will have it, so it'll be much worse.
Yeah, it would be far better in the future if we just send all the robots. We couldn't even, why not? It's a psychological thing as much as a human thing. Because in the old days, you just sent your best champions, the two best champions to fight it out to decide. So it's only sending all the robots. It's just one step up to that.
They're just one of the thousands.
Yeah,
They can't get knocked down.
Yeah.
Well, would that become that if the outside factory is pumping out all the equipment, then it'll just be a matter of trying to get a missile to try to knock that factory out, to knock all the means of production. So basically, sure, you can have that, drone versus drone, but then it'll just become, okay, how do we try to cut off the supply, and you basically just get more layers and layers out of it.
Yeah, the country with the best production logistics wins. And in that case, why don't you just take it one step up in terms of comparing Excel spreads? We're going to outproduce you, and my Excel spreadsheet is better than your Excel spreadsheet. Then
As in, it's going to go from drones to missiles.
But you have countries now setting up their own fab labs. So therefore, you're getting that independence. And that's the precursor to massive change.
Oh, yes. So yeah, definitely, as I said, revolution in military affairs. Okay, let's move on. I don't want to take up too much of your time. More about robotics. This slide will be available on YouTube or something. If you're interested. Yeah. So hence the caveat at the start of the. Not that I can enforce technical rules on everyone. I don't think so. Anyway. Who knows? You've only been with us half an hour. Okay. Advanced. Okay. So the third leg of this is the AI, what we refer to as algorithmic warfare. Again, currently, what it's being used for is basically just efficiencies. So making supply chains more efficient by optimizing the algorithm to deliver the food, the water more efficiently, the fuel more efficiently. Companies such as, say, Palantir are using their technologies in terms of predictive abilities in terms of both maintenance and also coordination of the battlefield. So strategic decision making. So I think their system is called Gotham or something like that, used by the Pentagon and various other militaries to help get that real-time picture of the battlefield. In future,
on the previous two, do you feel they're using advanced AI or like regenerative?
Well, certainly Silicon Valley is the Googles and the Microsoft are the leaders in this, and the military just plays catch up. So you don't have your best and brightest, working for the Pentagon, that sort of thing. But eventually they co-opt, contract, and get access to these things.
Most of the maintenance systems are just sort of 1980s style predictive analytics.
Yes, so yeah, that's the lower end. That was just examples of the lower end of these algorithms, but the higher end is the Palantirs and the other data space systems that are being rolled out.
They're on YouTube if you want to watch them.
And realism.
And then generative, yeah. So,
Okay, moving on. So again, target identification and recognition is an AI function. Cyber warfare and security, cybersecurity. That's a presentation on it all in on its own. I'm not going to go into too much detail about that, but definitely something that AI and the algorithmic warfare is definitely getting headspace on. Okay, this is just an example of the autonomy taxonomy that you start off small and you end up replacing the people. Basically, that's what the slide is getting at. Okay, let's get on to the more sort of discussion type part of the presentation. So as the research evolves, so does the AI applications. So you eventually what you will get is what is currently being discussed is for the future autonomous weapons. What are the legal boundaries in which they operate under? Because they're not. Under the Geneva Conventions, you've got the concept of the lawful combatant, the soldier in uniform subject to a chain of command that is punishable by the laws of war, the Geneva Conventions. So if the drone goes bad, who gets punished? Is it the operator of the drone? Is it the manufacturer of the drone? Is it the person that wrote the algorithm? Because certainly you can't put the drone in jail. That has no effect in itself. In terms of state accountability for its actions, is the deployment of these systems an enabler in terms of international conflict? Does it give the political leadership less, more, I wouldn't say incentive, but less pause for starting a war because they're simply sending in the robots. There's no human consequences on their side, and therefore no political cost for them in terms of. And you saw this during the Iraq-Afghan conflict, where drones were deployed for those targeted assassinations. There was a bit of plausible deniability if things went wrong, and also it's using an autonomous system. A lot of time over the airspace of a country that did not agree to have that drone in its airspace. But as I said, in international law, a lot of time Mike is right. You don't have to ask for permission, especially if you're Russia or the US. You simply fly the drone in. If it gets shot down, well, it was probably illegally over someone's airspace, but there's no pilot to rescue. There's no less accountability for that sort of thing. If there's a diplomatic incident, you just either say sorry or you deny, that sort of thing. Prevention of unintended harm and minimization of risk and indiscriminate use. So what we're talking about here is collateral damage. So unintended. So most militaries only go after military objects and lawful military targets, but a lot of time things go wrong. You've got the human civilian casualties, which is unfortunately given the term collateral damage. What is the legal issues, conundrums that are thrown up with regards to potential increase in collateral damage? Although the system targets better, the more use of these systems will undoubtedly lead to more collateral damage because more use, more probable collateral damage, that sort of thing. Some of the things that I addressed in my paper with regards to this is the importance of clearer rules of engagement when using these systems. So rules of engagement are basically code of conduct in terms of operations, that is a distillation of Geneva Conventions and the type of operation you're operating. So and it gives orders for use of force. So you're authorized to use force for X, Y, and Z up to a certain level. So if you give clearer rules of engagement in terms of higher levels of authority to engage, then that could reduce collateral damage. That is, if you're targeting something and you estimate, say, 100 collateral damage, then only a commander of a certain rank, a certain level, can authorize that. And any higher, then it goes higher up the chain of command. So say 500 collateral damage, it goes from the field commander to the theater commander to authorize that sort of thing. So that could minimize the risk of these use of these systems, possibly. But the discussion.
So when you say 500, you mean people or
Yes, the collateral damage is only about if you can take out 500 soldiers, that's
See,
all
this
the
is this is the
put a
problem.
medal on the
so
back.
if the soldier's not considered?
Yes, yes. So, I mean, the more you can take out of it, yes.
Yeah, this is the problem I have with the language, right? So collateral damage, it's human beings. It's killing 500 human beings.
Are children considered?
Surely,
humans?
everything that was
What? Collateral damage only refers to civilians. If you're in a warfare situation, the more soldiers that you can take out, that is your job as a military.
So that have algorithms that would have a guess at the collateral damage,
Yes.
right? And then make a decision of go or stay. And they have to draw a line, what was acceptable death and what was unacceptable.
Yes.
What would happen if one side was following the Geneva Convention and the other side wasn't?
It doesn't matter if the other side doesn't follow Geneva Convention. It's Australian policy that we follow. We've ratified the treaty, and it's part of Australian law. So we always follow Geneva Convention, no matter what the other side does.
Right.
We try.
So there's no talk of a treaty regarding autonomous.
There is talk, and that's it. That's in the next slide. So yeah, these things.
How this applies to the missiles you were mentioning earlier that are already
Which missiles?
the destroyer ones, the ones that are already human out of loop.
But those are only short range systems deployed on ships that for detecting incoming. So the incoming object has to be at quite a high velocity for it to activate. So you couldn't run at and have it activate. It has to the object coming in has to be at hypersonic speed for that to activate.
So what justifies that not having human oversight?
Because the time space in which you have to react to a hypersonic missile coming in at a ship is superhuman.
How would that be written legally?
It's all defense technologies are subject to DSTO oversight. That is, Defense Science and Technology Organization signs off on all the systems that we operate under. So there's always regulations as to all the equipment that we operate by the DSTO.
Because it's picking up missiles.
It's a defensive technology as opposed to offensive.
Yes.
So you're not choosing to attack people. You're defending a system against incoming attacks. So it's probably nuanced.
I was gonna say it's nuanced.
As a counter to all of this, surely the only way of countering a drone or a swarm is with lasers. Right? Is that, are you part of that deal too or not?
Okay, I think I've given the wrap up here, but thank you for your attention, and I hope you
Dan on the way out as well on the correct side. Next up. Yeah, that's okay now. Get some more. Do you guys want to do one more break before Luke jumps on? Just a quick bathroom break. There's some more beers here on the table. I'll set this up. But yeah, Luke Turner presenting next on brand computer interface with VR. It's okay. On the way out, it's all right. That was great. Oh man, that was awesome actually. Let's take it and see what where it's at right now. Yeah, let's see if I can set my recording as well. I think it's still going. All right, let's do full screen. It's going full screen. Yeah, view.
Slideshow? Yeah, slideshow. Yeah, slideshow. There you go. All right. Click with the. Use the wheelie thing on it if you want. Oh yeah. I'll just scroll through. Laughing real quick. Yeah, good.
All right, good time, guys. So we're going to final talk over here from Luke Turner. Round of applause for Luke Turner. Sorry, guys. Luke Turner just wrapped up over at, it's just on UTS actually with Dr. Avinash Singh. So studying in on the brain computer interface side. He's also doing a startup at UCAT, VR, and BCI as well. So another round of applause for Luke.
Thanks for organising tonight. Really appreciate it. So yeah, my name is Luke. This is me here. So I'm a master's student at UTS. I'm kind of on the other side where I'm just starting my thesis. So I'm looking at brain-computer interface and virtual reality technology in the field of skill acquisition and learning, which we'll get into in detail. So this talk is going to be about my thesis and my proposed research. I also work at a startup called UCAT, which is we have a nice little robotic cat, which is our mascot. And we work with paralyzed patients to try to restore speech and movement using brain-computer interface. So we work with labs that are decoding speech from the brain. So someone puts a certain word, and then we detect what that word is, and we add a VR layer on top of it. So there's a few moving parts. It's a little bit complicated, but I'll get to that at the end. So I wanted to think about this concept of intelligence augmentation, right? So this is something we talk about in transhumanism. Is this idea of upgrading our intelligence? And so very broadly, I see it in three kind of phases. So where we're at right now, or where we have been for some time, is just a one-way communication from the internet, or even previously through books and libraries and that kind of thing. So we consume information, we write it down, hopefully we remember it, and that's kind of how we learn, or we learn from a teacher and they're dictating to us, right? What we're kind of entering now is this stage of neurofeedback and using brain technologies to reinforce this process. So basically, we're using technology to detect what's going on in our brain as we learn, and then reinforcing that so that we can learn more effectively, which will inevitably lead to things like AI being implanted in the brain. So this is like the most hazy and kind of unknown part of this path at the moment. But you'll see how this research could tie into that kind of outcome. So yeah, today we'll be focusing on this middle phase, and this is what my research is looking at. So you need to understand a little bit about the brain in order to understand this talk. So our brains have this incredible ability to change, right? So every time we have an experience in life, there's a physical change happening in the brain known as neural plasticity. And so this is a concept where neurons in our brain are firing and talking to each other. And the strength between those two neurons is becoming stronger and stronger over time. So every time we repeat a skill or perform an action, we become more familiar with that skill, and it becomes easier and easier to strengthen that connection over time. So what we're doing with neurofeedback is using EEG, which is basically a set of electrodes that one can put on their head, or a small, electrode arrays that detect electrical signals, which happens anytime the brain fires and does anything. As they're performing a task, they're going to wear one of these headsets, and then some of their metrics and performance statistics are going to be displayed to them on a screen, or orally, or haptically. Somehow they're going to get some sort of feedback on how they're doing with this task. And then that is going to, obviously, they're going to read that, or they're going to listen to that, and their brain is going to understand, oh, okay, I need to course correct right now. I need to change my performance in this way or that way. And so this way we can kind of recursively make a loop of feedback in order to have the most optimal learning possible. So if you think about a traditional learning model, we have one teacher and maybe 30 students, right? And there's a lot of difficulty with that, because maybe, one student is a little bit further ahead than another one. Maybe another student doesn't quite grasp a particular concept. There's many issues that can arise. And a teacher doesn't have the time or the resources to create 30 different curriculums, right? And so what happens is a lot of students end up, left behind. So one possible future is we use BCIs and VR to have individualized learning curriculums that is perfect for your brain, right? So we could have each task broken down into 30 different subtasks or slightly different tasks that will allow all students to proceed in their learning and to benefit, right? So caters to different skill levels. Another benefit is that unconsciously we may be committing errors in the task we're performing, but we might not know. But this could be detectable at the level of the EEG that's on your head. So this could provide even more benefit than, say, a real life coach or teacher who may not pick up on that. And then eventually, hopefully, we can make predictive models of how difficult content needs to be for each student. So let's say you're using one of these systems and it'll say, okay, based on your performance, in 2 weeks, you need to look at this content. This will be perfect for you. in 1 month, you need to look at this content, this will be perfect. Or maybe this is too difficult and we need to take it back. So VR is already fantastic for this. There's a lot of research that points to various aspects of VR being fantastic for learning. So these complex environments that we can be in are really, really conducive to learning, as we've found. So in VR now, there's a lot of programs, particularly in the medical sphere, for medical training, where people have a virtual avatar of a cadaver or a heart or a brain in order to learn more effectively how to interact with that organ and learn about that organ. And this has been very effective. It's also highly interactive, so instead of just writing something down and listening to something, you're actually grabbing it, you're using your controllers, you're hearing things. It's completely immersive. And haptic feedback with vibration and that sort of thing plays into that as well. So on top of this, what I want to do is use brain-computer interface to monitor the state of a user while they're in a VR experience. So they're in a VR learning experience, they're learning a skill, they're being educated, and simultaneously we can detect how engaged they are. So is it too easy? Is it too hard? Is it fun? Do you enjoy that kind of activity? And also the cognitive workload, which is basically just determining how much strain is being put in the brain right now. Like, yeah, if this task is super easy, then it's going to be a low cognitive workload. If it's too difficult, it will be a high cognitive workload. So it's about finding that perfect balance. So to give an example, let's say we're teaching someone how to fire a bow and arrow in VR. And so there are lots of archery VR programs that I've used, and they're really fun. Well, what we want to do if we're trying to teach them this skill optimally is keep them in this flow state using these neuropsychological markers that I just mentioned. So let's say we start out super close to the target, we're hitting bullseyes 90% of the time, feeling good, but then eventually you're like, oh, this is kind of boring. Like, I'm not really progressing, right? So the engagement is low. Additionally, the cognitive workload is low. You're not really having to spend any mental resources on this task. So you're more likely to be distracted, pull out your phone, whatever it is. So eventually we can detect this and it's like, boom, this is a perfect distance, right? So we have a high level of engagement, we're having a lot of fun, we're optimally getting better at this task, and our cognitive workload is such that it's enough to drive us, but it's not so much that it's too much. Some time passes, and then eventually maybe this person fatigues, right? So now they're not engaged anymore because they're just too tired, right? So time is another factor that we have to take into account when we're creating these optimal schedules. And the cognitive workload is going to be too high. You're going to start to get exhausted. It's not going to be good. So at this point, we're either going to move the target back to be closer or just take a break, right? So spacing these tasks out and having optimal breaks is another really important aspect of this, and I'll come back to that in a second. So some applications of my research that could come out of it. The only picture I could find for this, I thought it was quite funny. So basically, if I would love, my dream is to have a generalizable model of learning that we can apply to any task. So you could have an API where a teacher is going to plug in their particular curriculum, or someone's going to plug in their particular task, and hopefully it doesn't matter what the task is. It just matters how engaged are you and how much cognitive workload is going on. So this could have massive effects. If in the future when BCIs and VR are much cheaper, it works better, it's faster, we have better learning algorithms, everything trickles down. I think this could be of a lot of benefit. Also, existing psychological theories and neuroscience theories could be gamified and applied to this sort of BCI VR system. So one such model is the spaced repetition effect, which basically says that cramming for an exam is not actually as effective as having short bursts and then having breaks. Because in the breaks is when your brain actually puts together that information, especially during sleep. So, this paper that I found was basically explaining that in neuroscience level, at a cellular level, which found that, it's much more effective for long-term potentiation, which is basically the strengthening of neurons, as I described at the start, over time. It's much more effective when you space it out. So we can plug this into the algorithm as well. Another kind of theory that we can look at is this zone of proximal development, where this point that you're at now is your current skill level, this yellow dot, and this outer ring is a task that is just going to be impossible for you. So your range of ability is kind of in between there somewhere. And so in this model, we have a teacher or someone helping the student. So initially, they handhold them a lot. There's a lot of training wheels. They're going to give them a lot of hints. And then over time, they'll reduce that amount of help, right? And so this is called scaffolding. It's a gradual reduction of help for the student. And my idea is that we could also gamify this. So we can have a VR program where initially it gives you a lot of hints, a lot of visual cues, it's super easy. And then over time, it helps you less and less. You're more on your own, but simultaneously you become more competent. So you're actually effectively learning in a very efficient way. And ultimately, I just want to talk a little bit about my other work, which is using invasive brain-computer interface. So for people that are paralyzed, this is our main demographic. So they have invasive brain implants, and the decoding algorithms for speech, which is essentially to say they think something and the text comes up on the screen of what they were thinking, is becoming extremely effective. So it's at about 65 words per minute now, which is faster than most people can type on a phone. So some of these paralyzed people are going to be able to communicate faster and better than able-bodied people quite soon, even now. And so we're hooking these up to virtual avatars as well. So to regain that autonomy that people have lost through paralysis, we give them a face, we give them emotion, we give them expression. And so this is some of the work that I'm doing. This is our little robot cat. This is UCAT. And so this is our dream. This is a prototype we're building right now. It's a VR experience for paralyzed patients who have an invasive brain-computer interface, which is a mouthful. But essentially, we're trying to restore speech, restore motor function, and end paralysis in the metaverse. So it's a lofty goal, but we're really excited. So that's it. Thanks.
I think the question, and great presentation by the way, is there anything around PTSD where there's really established long-term potentiation that you think this sort of system could be adapted to have a remedial effect or in some way?
Yeah, for sure. So I've seen examples of that in a VR setting without the BCI so far, but there have been VR simulations where soldiers who have PTSD go back into a simulation of a war environment, which can be triggering for sure, but they're accompanied by a therapist and it's all consensual and it's very gradual. And that's been very effective. So, the immersion that I described for learning, it's all the same, right? Instead of learning a skill, you're learning to, not be so afraid of life. Like you're learning to get over your trauma, right? It's like the brain is working in much the same way. It's just highly emotional, traumatic content, right? Which you have to be careful with. But absolutely, yeah, there's definitely markers that we can look at to say, oh, maybe this is too much. Your brain is freaking out a little too much. There's emotional models that you can use to do that. Yeah, many ways to go. But yeah, absolutely, that's a great experience.
Nice, great, really exciting technology.
Yeah.
I've just bought an emotive EEG, so I'm looking forward to playing around with that stuff.
Yeah.
I remember I bought one maybe 10 years ago, and you couldn't do a huge amount with it. But my whole thinking was, okay, I get the EEG, I build like a neural network, and then I train it to do something. I guess I'm interested. So with the EEG, you're talking about like reinforcement learning type stuff. Well, maybe I'm, maybe you're getting it a bit wrong, but. So how are you training the models? What I mean is, okay, you've got the EEG, you've got someone trying to learn something, but then you need to train the model of the EEG output in terms of what is actually benefiting, what is actually learning.
Yeah.
So then, yeah, I guess what's happening around that from a machine learning perspective?
So yeah, good question. In my case, the models are being trained around whatever markers we're looking at. So I looked at engagement and cognitive load, right? So there are already a lot of data sets out there publicly to pre-train a model to detect that. So that said, you do need to train it for the individual user. So it takes quite a lot of trials and a lot of training to get the data to a point where you can reliably detect if someone is engaged.
I mean, would you be asking users questions? What I mean is like, okay, so you want to look at how fast someone's learning. So then you need to be able to test to figure that out, right? Based on
Yeah.
that. You've got the EEG output, but so what, right? You need to then measure that against something quantified.
So the quantifiability comes from the game design, but the EEG accuracy is only really useful in the initial phase of are you engaged or are you paying attention or how much cognitive.
So you're just using it for attention.
Correct. Yeah, or both of those kinds of states, right? Or like it doesn't really matter what the state is. It's just some psychological or neurological state. But then you're right. The game. So this is the idea: is the VR experience should change in response to that, right? And then yes, there'll need to be a metric to say did you learn correctly, right? Whether that's like did you get the target enough times or whatever it is, and that can feed back as well. That kind of makes sense.
Does it need to change differently depending on the approach to the task? Like say I want to pull the archery bow back this way, but then for some reason I decide to reverse my hand grip on the remote. Of course I'm going to be facing a different workload.
Right.
To like try and pull it back.
Yeah, for sure.
So is that handled already in the training?
So yeah, that would be something again in the VR game design that should be accounted for. So yeah, depending on the variables of how the rotation of your arm, right? You can say like, okay, that's wrong, and then the user can be course corrected in that sort of way. I guess the use case here is if the technique is more or less correct, but they just need to practice the actual skill. If that makes sense. So they're in a perfect technique per se, but they're doing it within the bounds of the game already, and then we're just getting into that next level.
Limitations. Anything that jumped out to you that you'd like to highlight?
Yeah. So what I mentioned earlier, the training time is quite laborious. It takes a while to personalize these machine learning models. Can be ergonomically annoying. So what a VR headset can be. There are headsets now that are combining the two into one device, so that's kind of tackling that problem. People are afraid of PCIs. That's another thing. They, think it's Neuralink and that sort of thing, and which is the same technology. It's just invasive instead of, and they get really afraid, which is understandable. And there are definitely scary aspects to it, but they just don't understand it initially. So there's a barrier to entry. Like I have one of those EG headsets as well. It was the news, and I gave it to my girlfriend, and she freaked out. And it took 20 minutes, like for me, like it's fine, like put it on, and that was just like a meditation app. Those are the big ones.
What about so the cognitive workload is being on range, and so for some, the cognitive can get money regular or can come for benefits of the individual. How is that taken into consideration? Finding an optimized, not giving them that opportunity to test those.
So you're saying like a generic range of skill as opposed to like
that cognitive workload, right?
Yeah.
And they're optimizing that being changed, right? Any consideration about when does the game change in people? And could the individuals be missing out opportunities to stretch themselves just that little bit more if the game changes a little bit too quickly?
I see. Yeah, well, that's a really good question, and that's a question of calibration. But I think ideally it would have, your range of cognitive workload. Like, what do you find hard? Right? Like, and there would be some training. You could train fairly initially.
Yeah.
Right? So the range wouldn't be the same for everyone. Because someone might have already know it. Maybe it's super easy to know something, right? And they need a really good job.
Tough one because sometimes we think it's too difficult, but we
Yeah.
surprise ourselves.
That's right, and there's a lot of research pointing at this idea of just pushing past that point of difficulty where you find it's a little bit too hard, and then resting is optimal. So that's also, like I mentioned, existing psychological theories can be applied, right? So
Yeah, In the example you talked about with the 3 patients,
Yes.
doing word recognition,
Yeah.
or at least word creation. Yeah, I think you said that was an invasive.
Correct.
Yeah. So from your research, are we getting closer to sort of non-invasive technology that can get the same level of?
It's a really good question.
Like fMRI mold is one that I'm thinking of.
Yeah.
Oxygen level differentiation.
For speech detection, the non-invasive is still quite limited. So, you know, you see these paralyzed patients, and they're obviously quite willing to undertake a surgery and put a chip in their brain if that's what it takes, because they can't speak, they can't walk, you know, they're in wheelchairs. But cognitively, they're completely intact. It's just the connections to the peripheral nervous system that's the issue. So yeah, the non-invasive technology is still lagging behind. I don't know if there's a physical limit to that, because I don't know if it's a bottleneck of the algorithms, or if it's a bottleneck of you just need to be on the cortex to see that information at that sort of granular level. I don't know the answer to that yet, but yeah, it's hard.
Can I ask just with the invasive, the informed patient consent for that, is that just because the guardian has given that consent, or is the patient giving the consent?
When I say they can't communicate, there's various levels. So some patients with locked-in syndrome, which means in a wheelchair and can't speak, they have slight amount of movement in their neck or their mouth, so they can use a straw to type on keyboard. But I've never actually looked at the ethics regulations for that. But I do know from seeing some interviews, like this lady just watched this video today. She does an interview on YouTube. You can find it. It's Berkeley, University of Southern California, I think. She does an interview with this avatar, and she's talking about the benefits that's for her. So presumably she's
because it's an avatar that could have been generated.
Well, that's true, and it would.
I think that's the average actual show.
No, what I'm saying is they could have made that.
So
it's the same whatever they want.
You're right. I back the research though. I mean, from words I've seen decoded. I mean, I haven't looked at the actual EEG data for this lady, but yeah.
She is able to use very slowly another.
That's right.
So she couldn't make consent that way.
Yeah, that's right. Yeah, we're saying, but it's a good question. Yes.
Hi, great presentation. I
Thanks.
love the topic. 2 questions. I'm sorry, I'm raising my voice.
Sorry.
The first one's around the role of the observers and that idea that you're not there in the forest to hear the wherever to hear the tree fall, we didn't make a sound. It seems as though internally we put our own biofeedback back in terms of education and reinforcing those pathways we want to reinforce for example, right? But relying on external people, you then become dependent on a sort of a third party to a relationship rather than the healthy two-party relationship. Your thoughts on that observer effect?
Yeah, it's a great question. Not something I've thought about a lot, but I think my gut would say that, you know, in the age of distraction, most people are complaining about a lack of being able to focus and get work done and learn effectively and that sort of thing, especially in schools. COVID, ChatGPT, TikTok, with a million issues, right? So I think in general, people are kind of looking for maybe some sort of assistance in that way. And maybe traditionally that assistance has been a tutor or a coach. And outsourcing that to a machine may have effects that we don't understand. That's true.
But I think we're already overstimulated. There's already an excess amount of trying to, you know, tap into our dopamine responses. So this is another way of just tapping it basically from the brain.
I don't think so, because it's quite tailored to a specific educational outcome. So, you know, its goal is not a social media company that wants you to watch more dumb videos, right? Like its goal is specifically to get you to learn and focus and pay attention. So I don't necessarily see that as an ill effect. And also it's important to consider how effectively people can learn when they're playing games too. Like VR games or other types of games have been proven to be quite effective for learning, especially for younger generations that are very much acclimatized to that environment.
My second question relates to the read and write function.
Yeah.
It seems there's a lot of read, and there's noise that it has to sort of interpret through.
Yeah.
How far away from the write function? I know, everyone's talking about recording and memory, so you can upload them to the website and things like that, but that's a bit of a write function. Are we close to it?
So yeah, you're right. Everything I've described is read, right? So it's all passive. So it's what is already going on in your brain. Let's just figure out that and then turn it into data. But in terms of write, we have some sort of early studies of transcranial magnetic stimulation. I've seen recently there's something stimulating a small electric shock prefrontal cortex can help you focus. I'm not as up on the literature with that side of things. And there's not as much research being done because the ethical approvals are much more laborious. But I think that will become clear the next 3 to 5 years. Could be very effective.
The visual cues through the optic nerve the right function. The VR is providing the right function.
Exactly. So that's what I'm getting at. It's like
that is shaping the plasticity of the.
But at the moment, it's still digital to analog, eye, to then back to electrical.
Totally. It's not directly digital.
We don't have a direct mode. We don't have a direct connection.
Exactly.
So simply you can't write from analog. So that's a far older primitive. You can't.
Yeah, that's a fundamental question. That's sort of like
it's more of a computer science problem. The problem is when we talk about read and write, you're writing into a data structure that is so primitive, like it's so basic, like an integer data structure, or like even an array type, or even like a complex object type data structure. So basic. Right. It's like
a record. It's like an LP. It's an impression-based system, which is repetition.
Data structure. This data structure is so. This is like infinitely more complex.
100%.
We don't have an analog in computer science.
So there's some research being done in like to that goal of understanding every single connection in the brain, and then from that will become effective writing solutions to the brain. But we're so far away from it because it's so computationally expensive. So we have 86 billion neurons, and they can all have data and talk to each other. So it's a big number. Really
There are already patents in that space. And it's used for surgery.
Yeah.
Because until recently, you don't know what's happening through.
That's right. And we still barely understand the brain itself.
So no matrix style jiu-jitsu learning for me.
Well, I mean, so scared to my business.
Cool. Any questions? Round of applause for Luke. We do have one more speaker on Web 3, which is Bo Williams here. So hands up if you still keep going on. I mean, we've got close to 8:30. But you talk like every single week. Yeah, he speaks every week. I think everyone's exhausted, but maybe we can just network. We can speak to Bo and he can present. Yeah. Yeah.
I joined with the Australasian Society for Buddhism of all volunteers who are just really passionate about these types of topics. And so on our YouTube, there's the live ones on whether or not you're criminally responsible should, basically brain be interfered and then we have a greater propensity to act rather than to hold back and not act on impulse. So there are all these really interesting legal and ethical questions with the work that you're doing. It's brilliant work. But it's
a minefield.
Yeah.
Yeah.
AUSCL is the acronym, and so very welcome to have this.
Yes. Yeah. Yes, feel free to finish up with drinks if you want to sit up. But, yeah. All right. Yeah, just a second.
Oh yeah, that's I've got a modern computer. After recording. Sharing. Hey Michael. Say mate. Have a good night.
Bye, Lisa's on AI. There's so much going loose. Oh, so fun. I know. Oh, so